Welcome back to the Deep Dive. Today, we're giving you the ultimate shortcut to understanding how complex systems communicate, especially, when AI is in the mix.
Exactly.
We're not just going to read you some definitions. We're really unpacking the architectural consequences of two fundamental technologies.
And these are just technical acronyms. I think that's the key thing. They represent two, well, fundamentally different philosophies for how computers should talk to one another. One is kind of the flexible, well-traveled international standard, and the other is more like a meticulously engineered single-language corporate system.
That's a great way to put it. Our two players are the long-standing industry champion, the API, the Application Programming Interface,
Yep.
and the challenger, which is advocating for total internal consistency. That's the MCP, or Model Context Protocol.
Both are designed to do the same basic job.
Right.
Facilitate communication between systems.
Sure.
Whether that's a mobile app fetching your bank balance or, an AI orchestrating some complex response. But their approach to that communication, well, it dictates everything about the system that gets built around them.
Exactly. So for you, the mission of this deep dive is to get beyond the simple definitions. We need to analyze the mechanics, understand the structures they create, unified versus fragmented, and figure out which one is best suited for the heavy lifting required by modern platforms.
Especially those integrating AI. That's the real game changer here.
It is. Okay, let's unpack this and start with the workhorse. Let's start with the standard pretty much everyone knows, or at least uses every day, the API. When we talk about the application programming interface, we are really talking about the ubiquitous backbone of the internet. It's how a client like a web browser or a mobile app gets what it needs from the server.
At its core, the API is, functionally, it's a contract. It defines the rules and protocols for how a client asks for information and how the server is supposed to deliver it.
And its brilliance is really in its simplicity, right? And its reliance on these established standards.
It is. And when we look under the hood at that exchange, the foundation is almost always HTTP.
Right. It's inherently a web technology.
Precisely. The client kicks things off by sending an HTTP request. This is usually a verb, telling the server what to do.
Like GET to retrieve data, POST to submit something new?
Exactly. Or put as update, delete to remove. These are concepts that are really familiar to anyone who works with these kinds of systems.
But the beauty, and I guess the complexity of the API often comes not just from that initial request, but from the delivery infrastructure that's actually supporting it.
Oh, absolutely.
There's a lot happening between the client hitting send and the server returning that data.
So much. That request first hits what's called an API gateway.
Okay, what's that?
You can think of it as the main post office. It handles routing, security, making sure you're not sending too many requests at once.
So it's the traffic cop.
It's the traffic cop. The gateway then forwards the request to the specific destination, the API endpoint. And that endpoint is often like a microservice or a function that's designed to do one very specific task.
Like querying a database or running a calculation?
Exactly. And then the data comes back. And here's where we move from the universal standard of HTTP into the realm of flexibility.
Which, as we'll see, is both the API's greatest strength and, architecturally, its biggest long-term headache.
That's the real insight here. I mean, while the request mechanism is standard, it's HTTP, the format of the return data is super diverse. You could get back JSON, you could get XML.
Or you might be talking to a GraphQL endpoint, which is a whole different ballgame.
A whole different structure, yeah. The developer has massive flexibility to choose the best format for that one, single service interaction.
But that choice comes at a price, a steep one, right? If your system is huge, we're talking hundreds of microservices, multiple teams, that flexibility suddenly turns into fragmentation.
It absolutely does. And administrative overhead. When you look at large enterprises, just managing API fragmentation is a constant uphill battle.
I can imagine.
You get versioning nightmares. Is Service A on API version 1 or version 2?
Yeah. You
have the mental load of different serialization methods, different security headers, inconsistent data schemas.
It's a mess.
It's a mess, and an API is essentially stateless. Every time you talk to it, it's a brand new conversation. Unless you manually manage that state, which just adds more complexity, we rely on them because they're so flexible. But when you zoom out, The system itself is often just a fragmented patchwork, all stitched together with bespoke code for every single connection point.
Okay, so that context, the high architectural cost of all that API flexibility, is the perfect springboard into understanding the MCP, the Model Context Protocol.
Right.
If the API is all about localized flexibility and these stateless one-off requests, the MCP seems to be solving the exact opposite problem.
That's the most important point to grasp, really. MCP operates not as a set of flexible interfaces, but as a single standardized protocol. It defines not just how systems connect, but the entire context of the conversation. Consistently. System-wide.
So let's drill down on the structure of that first. We still have MCP clients, the usual web and mobile apps, but what makes an MCP host different from a standard web server?
The host is designed from the ground up to be a standardized environment that can run really complex tasks. It could be a desktop system, sure, or a network host.
But in modern infrastructure.
Increasingly, the host is the system running sophisticated AI models in these big orchestration layers. Its job isn't just to respond to a request. It's to maintain a standardized context across multiple, often sequential operations.
So if an API uses GAT and POST over HTTP, what's the core mechanism for MCP? How does it work conceptually?
The mechanism relies on a single, universal, standardized schema for every single request and response. It's not about using different HTTP verbs. It's about ensuring that the metadata and the session state attached to every single message follow this universal protocol. Imagine a standardized manifest that has to go with every package in a supply chain. It guarantees that no matter which warehouse handles it, the meaning and state of that package are always identical.
That sounds absolutely crucial when we start talking about AI.
It is.
Because if an AI model is trying to conduct a complex multi-step workflow like, I don't know, analyzing a document, summarizing it, then generating a follow-up, it can't afford to lose the thread of that conversation.
Exactly. This is where the name Model Context Protocol really earns its keep. AI models thrive on continuous, predictable context.
Right.
Fragmented API calls often drop that context between services, or they require these massive, complex headers just to manually keep the state alive. MCP just eliminates that friction. The protocol itself enforces context retention.
So every client, every service, every AI model talking to the host.
They all receive and send information governed by the exact same rules of context.
If we connect this to the bigger picture, it means the adaptability of MCP isn't just about connecting different resources. It's about connecting those resources, like external databases or other AI models, while making sure they all operate within a single, cohesive narrative.
Yes, it creates a true stateful dialogue between the client, the host, and all the integrated AI resources. This makes it just perfectly suited for the kind of highly interactive, multi-service applications that define modern digital services today.
So the protocol is the glue.
It's the glue that keeps the AI from getting confused or, forgetting what happened in step one.
Okay, so now we have a solid technical grounding in both. The API offers flexible interfaces on HTTP, but that can lead to fragmentation. MCP offers a standardized, context-retaining protocol, which leads to unification. Let's shift our focus to the direct consequences of choosing one path over the other.
I think the fundamental difference really just boils down to the architecture. API is designed for stateless, specific transactions.
One and done.
One and done. While MCP is designed for stateful, system-wide context management.
So what does this all mean for someone who's, actually building a system? Let's contrast the resulting structure. If I use APIs everywhere, what am I wrestling with on a daily basis?
You're wrestling with fragmentation. That's the word. You gain speed for individual service deployment. You can spin up a new service in whatever language or format is fastest for that one task.
But you pay for it later.
You pay the long-term tax of integration. Every time service A needs to talk to service B, you need specialized code, often called a serialization layer, just to translate the formats, handle version differences, and stitch that context back together.
Whereas the MCP approach, leading to unification, that sounds great in theory, but I have to ask, doesn't that level of standardization enforce a kind of rigidity that just slows down development?
And that's the critical trade-off. It's the thing you have to wrestle with. With MCP, the initial development might feel slower. You have to rigidly adhere to the protocol's standardized schema.
There's more upfront work.
There is. However, once that standard is adopted, the long-term benefits are immense. Testing becomes simpler. New services can just plug in automatically without needing bespoke translation code.
And system maintenance is streamlined.
Completely, because you know exactly how every single component is supposed to communicate. You're swapping that short-term individual flexibility for long-term architectural stability and efficiency.
So the API is like a city where every neighborhood speaks different dialect, which is fine for local stuff.
Right.
But it's a problem when the government needs to send out a uniform set of instructions to everybody at once.
That's a great analogy.
The MCP, on the other hand, makes sure everyone speaks the same standardized language from day one.
It does. The API's fragmented nature forces translation and error checking at every single border between services. The MCP's unified nature means the core engine, especially if that engine is a complex AI model, always gets predictable, high quality, and fully contextualized input.
Okay, let's move from the theory to the application. For you, the listener, who might be deciding on an architecture for a new platform, or maybe you're evaluating an existing one, when do you choose one over the other?
The decision really rests entirely on the complexity of your workflow and the level of internal standardization you need.
So let's start with API.
If your need is primarily for specific service interactions, fetching stock prices from an external vendor or allowing a mobile client to retrieve a list of products, then the flexibility and the sheer ubiquity of APIs make them the clear choice.
And that covers a massive amount of the web today.
Most of it.
So where does MCP carve out its territory?
MCP is ideal when the system must prioritize standardized communication across platforms and services, especially those that require a complex, orchestrated state. Think about multimodal AI systems.
Okay, give me an example.
Right. If an AI needs to receive input from a user, then consult 5 separate internal knowledge bases, dynamically generate an answer, and then log the entire session state consistently across 2 different microservices.
That's a lot of moving parts.
It is, and the standardization and context retention of MCP become absolutely vital in that scenario.
And crucially, that's where the AI integration suitability really comes into sharp focus. It sounds like if your platform's main value is complex, multi-step AI inference, you almost have to lean toward MCP just to manage the data flow.
Absolutely. AI models don't just need data. They need context. And MCP guarantees that context reliably across every single layer of the interaction. You're essentially designing the whole system around the needs of that complex model instead of forcing the model to adapt to a fragmented series of REST calls.
But what if I have a huge legacy infrastructure? I'm running thousands of existing REST APIs. Is switching to MCP an all-or-nothing proposition?
Yeah, that raises a very practical constraint. And the answer is no. APIs are the dominant standard, so if full migration is incredibly expensive.
So how do you do it?
MCP tends to be introduced for new, high-complexity components, often the AI or the main orchestration layer. And then the existing APIs can interact with the MCP host through specific translation layers.
So it's more of a hybrid approach.
It is. It's less about replacing all your APIs tomorrow and more about choosing MCP to govern the most critical, complex, and context-dependent internal workflows. The key takeaway is still the same. Choose API for flexibility and external interfacing. Choose MCP for unified, high consistency, and stateful internal orchestration.
So this deep dive has given you, hopefully, the critical shortcut. When you're analyzing system architecture, stop thinking about APIs as just interfaces. Start thinking about the fragmentation and the cost they introduce over time. And when you think about MCP, understand that its standardization is specifically designed to solve the problem of context loss in these complex stateful systems.
Which is paramount for integrating AI effectively.
It is.
And this raises an important question for you, the listener, to sort of consider as you wrap up this knowledge. For decades, the internet has thrived on the flexibility and open standards of API and HTTP. It allowed for chaotic, brilliant, and, yes, fragmented innovation. But given the increasing centrality of sophisticated AI models that demand standardized context for optimal performance, how soon until large-scale platforms transition their core internal infrastructure toward unified standards like MCP, effectively creating these closed, hyper-efficient digital ecosystems that all operate under a single language?
So will the demand for consistent AI communication eventually force the entire digital landscape toward greater standardization? That's the billion-dollar architectural question of the decade. Thanks for taking this deep dive with us.